everyone, and welcome to another Asia session by Asia Focus Group Innovative. Today, we'll be talking about building scalable applications with Azure Kubernetes Service. I'm Raqeeb Riyaz, been working at 99X for a couple of years as a software engineer, and we use Azure heavily throughout the project from end to end, from DevOps to other services. So let's jump right into it. We'll be covering these topics today. So first off, we'll start off with what Azure Kubernetes Service is, what are the benefits you get from compared to an on-prem Kubernetes service, and then we'll talk about the different scaling options that are available in Kubernetes. So here we'll be talking about the different types of scaling, the different types of scaling options that you have, like manual, auto scaling, and event driven using KDA. And then we'll talk a bit about serverless Kubernetes in Azure and how that fits into the overall ecosystem with the scalers provided in Azure. And then finally, we'll have a session for Q&A. If you guys have any questions, we can take them up. All right, so let's start off with what is Azure Kubernetes Service. So Azure Kubernetes Service is a hosted and managed Kubernetes service provided by Azure. So what do you mean by it's a managed Kubernetes service? What Azure does is that it abstracts out the operational overhead of managing the master plane, the master control plane of Kubernetes. So all you have to do is worry about your workloads. So you spin up a cluster, you deploy your workloads, and you're good to go. You don't have to worry about the internal automated upgrades or the patching and all that. So Azure takes care of that for you. And then the benefit of having a Azure Kubernetes service is that you have high reliability and availability due to the massive Azure infrastructure that is provided to you. So you can rest assured that your workloads will always be highly available. And the most interesting part about the Azure Kubernetes service is, okay, so you have the master nodes running on the cluster, but are you actually paying for them? Well, no, because Azure takes care of it, and you have to only pay for the nodes that you deploy. So that's a really nice benefit of having it hosted. And then you also get into the other rich features that Azure provides. So like monitoring, Azure Active Directory integration, and virtual networks and all that. So when you spin up a cluster, Azure takes care of all of these, and all you have to do is just deploy your workloads and you're good to go. So let's just jump into scaling options. But before that, let's have a look at the different types of scaling that are available. So generally, when you speak of scaling, you can do it in two ways. So you have the horizontal scaling, which is you scale in and out. You increase the number of instances. So in our case, in terms of Kubernetes, you can increase the number of pods or nodes, and you can decrease the number of pods or nodes. And when you talk about vertical scaling, you have increasing the resources within a pod or a node. So these are two different concepts. So one is you increase or decrease the number of instances, and the other is you scale up or down the resource that you have. So when we talk about Kubernetes and scaling, there are three main theories sort of that you can use. So you have first the manual scaling. Here you set a defined amount of resources that you want. You set the replicas and you get that. And there's no fluctuation. There's no auto scaling involved here. What you've defined is what you get, and regardless of whether you have high workloads or low workloads, you'll get the same amount of replicas all the time. So then you have a different option called auto scaling. So here we'll be talking about horizontal pod autoscaler, the cluster autoscaler. And then finally, we have the event-driven ones, and we'll talk about KDA and how it plugs into your Kubernetes cluster and how it can provide rich metrics to scale off of. Yeah, so let's start off with scaling manually. So as I mentioned, you define a set amount of resources. So you set the replica count that you want, and you get that. And regardless of the traffic your workloads get, you will have that same amount of resources. So what's the benefit of this? That you have a fixed cost because you don't you don't need to worry about your workloads having a sudden surge of traffic. So you have a fixed cost in that. So when we talk about what can you actually scale in Kubernetes, you have the deployment, and then you have the replica set and the stateful set. So these three objects can be scaled in Kubernetes as of now. Yeah, so before we jump into the auto scaling, let's just have a look at a demo. So first off, I'll just show you what I have right now. So we have the Kubernetes cluster all set up. Yep, so I have it all set up. So we'll just deploy some workloads to it. So let me just pull in some commands. So here I've already connected to my cluster. I've already used the context and set everything up. So let me just switch to the namespace, and then we can create a deployment. So basically, we are creating a deployment with the image engine Nginx, and we are naming it Nginx. So let's just deploy that, and then let's just open up another window, and let's just watch for any changes on the deployment. So we're just watching, and right now we have one instance available, and the maximum instance right now is 1. So we have 1 of 1. So let me just pull up another command. So this is how we manually scale our deployments. So you call the kubectl scale command, and you provide the number of replicas, and then you specify which deployment you want to scale. So let's just hit enter here. And as soon as I did that, you can see it gives me back that it has been scaled. And what do we see in the other window is that we have 2 available replicas now. So we increased the number of pods within the deployment to 2. So this is how you can scale your resources in a deployment. So if we just change it back to 1, you'll see that it goes back down again. So this is how you would normally scale your resources manually. Yep. So if we come back to the presentation. So let's talk about the automatic scaling part of it. So here we are talking about the horizontal pod autoscaler first. So before I jump into this, I'd like to mention that the vertical pod autoscaler is actually not available in Azure, but it is available in Google, as I remember. And then if you talk about the horizontal pod autoscaler, what it basically does is allows you to automatically scale the number of pods that you have based on the CPU and memory usage. So this also works only on Kubernetes objects that can be scaled. So that is deployments, replica set, and stateful sets. So what it does is it monitors the CPU and memory utilization on a given period, and then it checks whether that resource utilization from the metrics API is fluctuating. So if it goes above the needed resource, then it'll spin up a new pod for you. Yeah, so you can define a minimum and maximum replica count, and you should be it'll scale from it'll keep a minimum of the replicas and then scale out to a maximum of what you have specified. Yeah, so let's just pull up another demo for this. So let me just pull up the commands for this. So I'll just show what I'll be deploying right now. So we have this deployment that we'll be deploying. So I'll just pull up this as well. So this is the actual server that will be giving that will be deploying. So what it basically does is it mocks sort of a heavy computation work. So it basically keeps doing this when we call the server URL. So coming back to the deployment, you can see we have the deployment, and we have specified the image over here, and we've specified the name. And this part is what is required for the horizontal pod autoscaler to work. So remember that I mentioned that you need it works on CPU and memory. So you have to provide this resources so that it knows how much CPU and memory you require. So in this case, I've set it up to have a request for 200 M CPUs, and then it can go up to a maximum of 500. And then I just have a service load balancer so that I can access the um, service deployment. Sorry. So let's just try this. So let me just go to that, and let me pull up the script for this. So now we'll just deploy, and before that we'll just switch namespaces. Yep, demo. Cool. We'll just deploy this. Give it some time. So we have our deployment and service now. So let's just get the service and wait for it to give us the external IP so that we can use it to access it. So let's just wait for a bit. Yep. So we got the IP. Let me just copy this. And what we're basically going to do is give some load to it. So let me just pull this up, and let's just up a so this, and then not sure why it doesn't work. Oh, there we go. Okay. So we will watch the HPA over here. So this is a horizontal pod autoscaler. So we haven't actually deployed it, that's why you can't see it. So let me pull up the HPA over here that we're going to deploy. So over here, you specify it's a this API version autoscaling/v1, what object it is, horizontal pod autoscaler, and we are targeting this deployment. So we specify that this is a deployment, and the name of the deployment is PHP Apache. Here we are specifying that we need a minimum replica of 1 running at all times. And then when you scale out, you can scale up to 10 replicas. And here we're specifying when you should scale out. So we are saying that if it exceeds 50 of the average utilization, then we will scale out to a different instance. Yep. So I think I should create another one as well, just to watch the deployment as it scales out. And we will deploy this HPA. So one way is to deploy it, or you can also use the command directly. So here I'm specifying that I'm using the kubectl autoscale command, and I'm saying scale this deployment when it reaches 50% CPU usage. Give me a minimum replica of 1 and a maximum of 2. So this is the same as using the deployment definition file. So let's just do that. So now we have it created, and let's just watch it. So let me pull up the actual command that we'll be using. So over here, what I'm basically using a existing load generator. What it does is it sleeps for 0.01 seconds and requests the URL. So if I just execute this, this is going to send a bunch of requests to the server. So over here, you can see once it has done the computing, it's giving me a response here. So we'll just watch the HPA and the deployment, and we'll be able to see that it's going to kick in and start increasing the number of resources. So let's just give it a second. because it has a period, it checks the resources periodically. Yep, I think that's enough of requests. We'll just wait for this to kick in now. And also watch the pods over here. Yep, so you can see it starts kicking in. It's saying that, okay, you've used 191% out of the required 50%. So now I'll start scaling out. You can see it has started creating new instances over here as well. You can see they were pending and now they're getting created and they are slowly running, and it'll scale back in once it's all done. Yep. So we are not going to wait for it to scale down. So we'll just go back and look at the next auto scaling component that we have. We have the cluster autoscaler here now. So basically the horizontal pod autoscaler works for the pods. It scales out and it scales in the pods. But if you want to actually scale out the nodes that you're working on, then you need to use the cluster autoscaler. So what it basically does is it monitors the pods and checks if there are any pods that are in the pending state. So once it sees that, okay, there are a lot of pods that are pending because the horizontal pod autoscaler went on and started saying that, hey, I need more pods because there is more workload. So the cluster autoscaler kicks in and starts scaling out the nodes. So now you have new pods that are in pending, but once the cluster autoscaler kicks in and creates a new node, you have the pods being scheduled into that new node. So it's typically used alongside the horizontal pod autoscaler, like I mentioned, and then it uses the virtual machine scale sets that is available in Azure. So what virtual machine scale set is basically, it allows you to create and manage a group of load balanced VMs. So when you have virtual machines, when you actually set up the cluster, you can switch between the virtual machine scale set or the normal virtual machines. So the benefit of using a virtual machine scale set is that you have one configuration, and all your virtual machines that will be deployed or that will be scaled out will also use the same configuration that you specified. So instead of having for you to manually go deploy the virtual machine and configure it, you can use the virtual machine scale sets to do it for you. So it allows you to replicate the VMs with the same configuration, and it provides high availability and high resilience because when let's say the customer is trying to access a virtual machine and somehow it has some issues. So after a certain, there'll be a small interruption period, but the customer will be able to access the same application through a different VM. So those are some benefits that you get by using virtual machine scale set. And here as well, for the cluster autoscaler, you can define the minimum and maximum replica count. So how many nodes you want running at all times and how many you want to scale out to. We'll get back to that demo, but first I'll talk a bit about event-driven scaling using KDA. So as I mentioned, the horizontal pod autoscaler works on the CPU and memory metrics. But what if you want to scale based on a service bus queue or a storage queue? So any external metric that you want or any custom metrics. So that's where KDA comes in. So it's an open source project, and it has a bunch of built-in scalers. What a scaler is basically uh, some objects that allow it to communicate with the external resource, for example, a storage queue, and then it pulls those metrics and feeds them into the Kubernetes API metric server. So what it does is it gives the information to that, and which results in the horizontal pod autoscaler being able to understand that, okay, so there is some workloads that are not related to the CPU and memory, but there is an external event. So let me just scale out to meet those demands. So the best thing about KDA is that it's actually pluggable. So you don't have to do anything. You just have to install it into the cluster, and it can be installed in any cluster, not only on AKS. So it's part of the cloud native computing foundation. So what it also does, an interesting thing is that it allows you to scale to and from zero. So with the horizontal pod autoscaler, you always will have a minimum replica count of 1. But with CADA, it knows that, okay, so there is no work to be done, so I can just scale down to 0, and it'll keep that until it gets some traffic. So like I mentioned, it leverages the Kubernetes API, so it doesn't have any inbuilt logic to scale the pods. So it keeps that work for the horizontal pod autoscaler. All it does is gets the metrics and feeds it into the API metric server. So it makes it really lightweight, and it does one thing and it does it really good. And also it plugs in a few custom resource definitions. So what I mean by custom resource definitions are like when you take Kubernetes, you have these inbuilt objects such as deployment pods and horizontal pod autoscaler. So all these are part of vanilla Kubernetes. So using custom resource definitions, you're able to create your own custom object and use it in the YAML file to define it as a kind. So we'll have a look at that. Yep. So let's jump into the demo. All right. So let me just close this. I already have a new one set up. Let me open, maybe close this as well and open the CADA. Yep. So this is the, let me just put that again. Okay. Okay. So we have the, sorry, got the wrong one. Yeah, so this is the application. So basically the structure of the application is we have a storage queue, a service bus queue, and then what we're doing is we have two applications. One is a processor, an order processor, and one is an order generator. So what we'll basically do is create some load using the order generator, put some messages into the queue, and allow CADA to scale based off those events. So we have the order processor here. So I'm using the CADA sample that is provided in the GitHub repo. Here we can see this is a normal deployment, and then I've specified the image. And the interesting part about CADA is that you can use the secrets separate from the same from your normal scaled objects, which I'll talk about. So if we have a look over here, we have created a secret and we've specified a connection string. So what this connection string requires is just the listen, because this is the consumer. So we just want the authorization rule of listen, and we'll listen to, it'll give the permission for it to listen to the messages. So we've specified a secret here and we've referenced it over here. And then if we have a look at the scaling object. So here we are using something called a trigger authentication, which is a custom resource definition provided by CADA. And we've specified here as well that it is a connection string with a connection string over here. So this is a base 64 encoded connection string. So the important thing to note here is that for CADA, you need to have the manage, send, and listen permissions for the CADA monitor, because to pull up the metrics, you need the manage permission. So make sure you set that as manage. And then here is another custom resource definition that is provided by CADA. So this is a scaled object. So this is where you specify the minimum and maximum replica count and the cooldown period and all that. So here, if we have a look, we specify something called a scale target ref. So like in the horizontal pod autoscaler, we are saying that we want this deployment to be scaled. And here you can specify a cooldown period. This I've just set it to 5 so that we can see it scale down as well. And apart from that, by default, you get the minimum replica count as 0, and the maximum replica count you can give anything you want. So again, these both things are configurable. You can scale out to how many instances you want. And then we specify the trigger. We say that, okay, so KDA will use the Azure Service Bus trigger. So there are different types of triggers available in KDA. So it's not only limited to Azure. There are different triggers available for other cloud service providers as well. So we've just specified the order queue, the name, and we've specified when to scale out. So in here, if there are more than 5 messages in the queue, go ahead and create a new instance. And we've specified the authentication reference over here, saying this is the secret connection string that you should use. All right. So we will deploy this. Let me pull up the scripts. Okay, so first we will deploy the application, which is the order processor. Let's just watch the deployments here. Okay, cool. Okay, actually, let me just switch to this so that we have a fresh set of namespace. And then we'll just watch this over here. Right, so you can see that we have one order processor running. Now notice when I deploy the autoscaler, the scaled object. So when we deploy this, you'll actually notice that this goes back to 0. That's because now KDA has kicked in and it's saying, okay, you have no workload. So let me just terminate that pod, and now we have 0 out of 0. Yep. And if we have a look at the horizontal pod autoscaler, you can see now it's scaling based on this target. So previously you could see it had a percentage saying it was the CPU. So now we have this out of 5. So right now we have no messages, so it says unknown. Right. So let me run the order generator. So what we are basically going to do is run the order generator over here and specify how many messages we want to populate the queue with. And based on the number of messages, we should see KDA kicking in and giving us more pods. So let's just run that. So let's just queue, maybe 100 messages. So now this is going to start queuing different random messages. I guess there is a small issue. Oh, I've specified the wrong connection string. 1 second. Let me just pull this here. I'll update the connection string and should work. Let's try that again. Okay, cool. Yep, so we are queuing the orders. Just close that. So now you can see it's, yep, so now it kicks in and it's starting to scale. So you can see it's increasing the number of uh, pods that are available in the deployment. And you can see it's having 45 messages right now. Yep. So let's just have a look. So it's scaling out to 8. So remember that we've specified 10 as the maximum count. Yep. So it should start processing all the messages. And we'll give it some time. Yep. You can also check what are the messages we have in the queue. So we have the queue here. We'll just go into that and we should see the number of active messages over here. So if you just refresh, you can see it has already processed all the messages. So now this should scale back to 0. Yep, so now you see there are 0 messages and you can see it has scaled down to 0 again. So that's the reason it happens so fast is because I've changed the cooldown period to 5 seconds, but by default it has 5 minutes. So just keep that in mind. Yep. So now we'll just have a look at the serverless Kubernetes in Azure. So just a bit about this and how it works along with the horizontal pod autoscaler and the cluster autoscaler. So what is Azure Container Instances? So we have two things that you can use to deploy your containers. We have Azure Kubernetes Service and we have Azure Container Instances. So what Azure Container Instances is it provides a way to deploy containers into Azure without worrying about the orchestration platform. So you don't need to worry about Kubernetes. Azure takes care of that for you. And what you have to do is just request a container with a certain size and you get that delivered inside Azure. So why would you, so why talk about ACI when it comes to Kubernetes? So it's because of virtual kubelet or virtual nodes as known in Azure. So virtual kubelet is a open source project and it's also part of the CNCF sandbox. It's also umbrella and it is a sandbox project. So what it allows is it allows you to extend your Kubernetes cluster into serverless platforms. So one of them being ACI. So it works with other cloud service providers as well. So what this does is it registers a virtual node into your cluster, and whenever required, it can burst workloads into that node when you've reached the maximum capacity, even after the cluster autoscaler has kicked in. So let's say you scale out to a maximum of 5 nodes in your using the cluster autoscaler, since that's what you have specified as your max replica count. And then you don't have enough resources and you see pods that are pending to be scheduled on nodes. So what virtual kubelet can do is it can act as a node and it can deploy your pods into that node. So it's a pool of resources that is available and ready to use whenever we want. And you are only charged for when you actually run workloads on it. So even though it's running on your cluster as a virtual node, you don't get charged for when it's just running. You only get charged when you run workloads on it. Yeah, and like I mentioned, it's vendor agnostic, so it can run on other service providers as well. Yep. Yes, so let's just have a look at that. So I'll just pull this up again and pull this. Let me close this one. And I'll show the deployment. So there is a small change that you have to do if you want to deploy your workloads into virtual nodes. So let me get the deployment file. So this is the same deployment file as I used for the order processor. The only difference is that you need to specify this node selector and this toleration. So what it basically means is that so when you have a look at the virtual node that is present inside your cluster, it has a taint called taint with these values. So what it basically means is that unless you explicitly specify that you want your pods to be deployed into that virtual node, it will not do it. So you have to specify this toleration that, okay, I tolerate this taint that you have provided in the virtual node, and therefore I can go ahead and schedule this on it. So it gives a really nice control for the end user, because now you know that your pods will not get scheduled into virtual nodes unless you specify explicitly. Because when you burst out to virtual nodes, it can actually be a bit expensive compared to running your clusters. So you only use it, the typical scenario is when you have a lot of bursty workloads and you want to run them quickly into the virtual nodes. So the benefit of using this virtual node is that it's already uh, spun up and it is available to go. So all it has to do is pull up the pod image and then it'll start running your workloads. Compared that to a cluster autoscaler, the node has to take some time to get ready so that the pods can be scheduled on it. So we specify these two nodes, node selector and the tolerations, and everything else is the same. We've specified the resources over here so that the cluster autoscaler knows when to scale up. So we'll use this same example because I've already set up the virtual node in the cluster. There's an option when you deploy, when you create the cluster. And I've also enabled cluster autoscaler already. So if we just do get on the nodes that are available in the cluster, you can see we've already scaled out to another cluster, and we also have the virtual node available over here. Yep. So let's go ahead and change what we deployed, because now this is different from the actual deployment that we had. They don't have the tolerations. So let me just pull up a script for this. Yep. Oh, sorry. The string has to be different. My bad. So the secret that I've provided is not correct. So if I just do that and apply the new one. Yep. So now we've come back to the auto processor and now it's running on. So now you should see it scheduled on the virtual nodes. So we'll just have a look at the pods here. We shall also add the wide option here so that we can see which node it's being deployed on. So now we don't have anything. So I'll just run a small amount of load here. So maybe 10. So you should start queuing up and we should see this being deployed. Oh, there's a small. Yep. So now hopefully this should. Yeah, so you can see it's trying to send it on the deploy it on the virtual node here. Yeah, so it has already terminated. Okay. Yes, I think that's it for the demos, and these are some references that you can use. So the Microsoft docs are really nice. You have all the uh, information, how to scale and how to set up virtual nodes and all that. We also have the KDA documentation, which explains all the concepts about KDA and also the virtual kubelet.